This is a video on percent composition. Have you ever considered before a chemical compound? Take for example water, H2O. Now you know, based on your limited experience in this chapter so far, that hydrogen as an atom has a mass of 1.01 rounded AMUs, and oxygen has a mass of 16 when you round as well. Now, when you look at the chemical formula for water, you might think, and it's reasonable to do so in the beginning, that it has more hydrogen atoms than oxygen. It does, but when you want to describe the percent of a compound by its mass, you need to take into consideration the mass of each individual atom. What I mean by that is the mass of water comes from 3 atoms, 2 hydrogens and 1 oxygen. But I guess you can see pretty quickly that if you have 2 hydrogens, that mass combined together is going to be 2.02, and 1 oxygen is going to be 16. When you add those together, the combined mass of all the atoms in the compound from the molecule is 18.02. There's 18.02 grams, basically, if you had a whole mole, or 18.02 AMUs, if you want to think of it as, for one atom, for one molecule, rather. Listen, the next concept you have to learn is very easy. I want you to take this idea that the molecule contains 2 hydrogens and 1 oxygen and convert those numbers into percentages. How do we do percentages? Well, percentages are always a part out of a whole. So to find the percent of hydrogen in that compound, you take the mass of both hydrogen atoms together and you divide that by the total. So you go off to your calculator and you type it in, 2.02, and you divide that by 18.02. You're going to get 11. Now, you're going to multiply that by 100 to change it into a percentage. So your calculator is going to say 0.11209. Multiply that value by 100, and that's going to give you a total of 11.21%. You can leave enough room to do that properly. And the hydrogen, that's the hydrogen. The oxygen component is going to be obviously much heavier. 16 divided by the 18.02, which is going to be the difference, which is going to be 88.79%. Let's summarize then. The amount of hydrogen inside that unit, called a molecule, although it's 2 atoms, accounts for 11.21% of the mass. And the oxygen accounts for the difference between that and 100, 88.79% of the mass. So although it has less atoms, it's still heavier. Percent composition is quite simple. You have to find your molar mass, and then take each element and divide it by the total to get the percentage. Remember to multiply by 100 to change from a decimal to a percentage. And also you should remember that we have a rule of thumb that we use for molar masses, which is 2 decimal places for every element. We're going to use the same rule of thumb in terms of percent composition. We're going to use 2 places after the decimal for every substance. So we have some examples to do in your booklet. The first one is calcium fluoride. So calcium fluoride is an ionic compound made of formula units. You have 1 calcium and you have 2 fluorine atoms in every unit. Calcium has a mass of 40.08 when you round it 2 places. Fluorine has a mass when you round it 2 places of 19.00. When you add that up, you're going to get 78.08. That's the mass of the whole compound. grams per mole, or just 78.08 AMUs. The unit doesn't matter in this case for the math, because when you do a percentage, percentages never have units. They're always going to be part out of a whole. So to find the percent for calcium, you're going to take the 40.08, which is the component from the calcium itself, and divide that by the total. And you're going to take the component from the fluorine, which is going to be 2 times 19, 38, and divide that by the total. So, 78.08. So 40.08 divided by 78.08 is going to give you, as a decimal, 0.5133. When you multiply it by 100, you're going to get 51.33. 2 places is a good rule of thumb, percent calcium in that compound. And the other one is going to be, you take your 38 and you're going to divide that by the total of 78. And you're going to get a decimal value of 0.4867 to 2 places, which you're going to convert to 48.67%. And that's fluorine, the fluoride ions, of course, in that compound. And of course, you know by now that basic math skills, those two numbers should add up and give you 100%. I don't recommend that you just do 1% and then subtract from 100 to get the second one, because in case the first one was wrong, you might catch it when you do the second one. They don't add up. So don't take a shortcut. Do them each out, and don't be, lazy. 100% is the check. Once in a while, your checks, you might get 99.99, just because of rounding sometimes, but very rarely. So ethanol. Ethanol contains 2 carbons. Ethanol contains 6 hydrogen, if you group them together, and 1 oxygen. So you're going to take each individual mass, 2 times 12.01, 6 times 1.01, and 1 times 16. We'll add these up. So the amount of carbon is going to be 24.02, 6.06, and 16. Add this up. Going to get 0.08. You're going to get 46.08. That's the mass of the entire compound. Now to do the individual components, take your individual masses and divide them by the total. So we'll start with the carbon. We'll do 24.02 divided by your 46.08. Now you can do that out longhand, or you can just sort of skip. Maybe write it like so. Calculator answer is going to be 52.13%. That's the mass of carbon in the compound. Obviously the hydrogen is very light. When you divide that one through, you would expect that it would be a much smaller percent. And there's 6 atoms of it, but still, 6 out of 46 works out to be 13.15%. And that's the percent for hydrogen. And then you do the last component, which is oxygen. Although there's only 1 atom in the entire molecule, it still works out to be a pretty significant mass, because the atom itself is quite heavy. So 16 divided by 48.08 is going to give you 34.72 when you round, and that's the percent of oxygen. If you double check your math, should add up to give you 100. If it does, you did it right. If it didn't, you screwed it up. And it works, so it's good. Question 3, there's a 2-parter. It says, calculate the percent composition of aluminum sulfate. The first thing you might be asked to do in a question like this is to actually figure out the chemical formula, what was already given. So there's 2 aluminum atoms, there's 3 sulfur atoms, and there's 12 oxygen atoms. So you have to start at the very beginning, write down each component. So aluminum has a mass of 26.98. Sulfur, on your periodic table, it says something different than what we use. I told you way back when. It's changed a couple times. I'm asking you to use 32.07. I know it's not what it says, but you're doing it because I asked you to and you love me. So 12 times 16 for your oxygen. We'll do each component separately, and then we'll add it up. Okay, so I add them all up. 2 aluminums, 3 sulfurs, and 12 oxygens. Do all the math, you should get 342.17. So now we have to find the percentages of each. So you take the component for each element and divide by the total. Gets a little bit messy in these close quarters here. Then you're going to convert each one into a percentage. So I'll do the first one with you live. 53.96. Divide that by 342.17. The decimal value is 0.157699. Change that into a percentage. By multiplying by 100, you're going to get 15.77. 2 places for rounding. Rule of thumb for percent composition. So this compound is going to be 15.77% aluminum. I'll do the rest off camera with my calculator, and I'll come back. So it works out to give you 28.12% sulfur and 56.11% oxygen. Together they add up to give you 100%. So take each individual atom, multiply by the number for the subscript, find the mass of each atom, find the total mass of the whole compound, and then find the percent of each atom by dividing the component by the whole to get the percent for each. Now part B asks specifically for the mass of aluminum in a sample of 88.9 grams of aluminum sulfate. We just did all the work that helped us to decide what percentage aluminum is in the compound. We learned that 15.77% of the entire compound is made up of aluminum. So let's just say you found a great big stash of a compound like this and you wanted to know approximately, say you had 3 tons or 5 tons or a huge amount out in the middle of some deposit on some land. You wanted to know how much aluminum was in it. You could do a simple procedure like this. Take the percent of the entire compound and multiply that by the amount that you actually had to work with. In our case, we've got 88.9 grams. So 88.9 grams, take that number and multiply that by the percent changed back into a decimal. So 88.9, multiply that by points this time, 1577, and that'll give you the amount of the 88.9 grams that's strictly from the aluminum. And mathematically it's 14.01953. And that you want to know, because it's aluminum, and you're given 18.9 grams, you can do significant digits of 14.0 grams of aluminum. So backtrack. If you had a sample that contained 88.9 grams of aluminum sulfate, and you wanted to know what mass of the 88.9 grams came specifically from aluminum atoms, you could find the percent of aluminum first, like we did in part A, and then take that percentage and multiply it by the actual amount to get the specific component from just the aluminum by itself. Now the last example is a little bit more difficult, I suppose you could say. So it says for each 10 kilograms of copper 1 sulfide, Cu2S, I say copper 1 because sulfurs are 2 negative, therefore reverse crisscross, it would be copper 1. So we have a compound, copper 1 sulfide, and we want to know how many kilograms of copper could we get out of that sample if it was 10 kilograms in total. So our job, first of all, is to find the mass of each of these atoms and do the mass in total. So let's look up copper and sulfur on our periodic table. We've got 2 coppers and 1 sulfur. Find the total mass, and then we'll do the percent composition. Works out to be 2 copper atoms, 2 times 63.55 when you round, and 1 sulfur of 159.17 grams for a whole mole. Now we want to know the percent of copper. How much copper in terms of kilograms can we get? This is not a gram conversion on the table using the green chart. This is a simple, we know how much compound we have, how much specific of the compound is copper. We take our copper amount, which is 63.55, we times it by 2, and that's going to give us 127.1 grams in total out of the 159.17, and figure out the percent. It works out to be 79.85% copper. That's a pretty good percentage for a compound. Do we have enough information to solve the question? Well, we could in fact just carry on down and say, well, we have 10 kilograms. So 10 kilograms of the compound. If I want to know what 79.85% of that is, take that 79, convert it back into a decimal, so 0.7985, and multiply it by 10. Do that right in your head. You're going to get an amount of course, 7.985. That's kilograms. 3 significant digits, 7.99 kilograms. There's 7.99 kilograms in a sample of copper 1 sulfide that was 10 kilograms in total mass. The other remaining bit, the 2.01 kilograms, would come from the mass of sulfur. Sulfur is about half of the mass of copper. So I hope that that's enough hint and help. Tricky kind of stuff is not that complicated, that you'll be able to go back and find the percent composition of any compound. Start with the chemical formula, write down your number of atoms, find the total mass, and then convert it to percentages. Remember to use 2 decimal places as a rule of thumb, and you should be able to do any of the percent questions you see coming at you in the future. Good luck.